Hello viewers, in the last film we had discussed about two very basic components, the resistors and the capacitors. Now in this film we are going to discuss three very important components, the diodes, the transistors and the UJTs. Now first of all let me take up diodes. Diodes, as you all know, is a unidirectional device and it works like a rectifier. Symbolically we can show it like this. These are the two terminals and there is an arrow have kept. What does it mean? It shows the current flow will take place from this terminal to this terminal. There cannot be any flow of current from this terminal to this terminal, and this particular terminal is known as anode, this is known as cathode. Now when I give a supply to this, I have to be very careful. Since it is a unidirectional device, I have to give a positive supply to anode and a negative to cathode. This type of connection is known as forward biasing, and as I said, it only conducts in one direction. This will only conduct while forward biasing is done. That means positive is connected to anode and negative is connected to cathode. If I reverse it, that means if I connect positive here and negative here, the same device is not going to show any conduction. That means you have to be very careful when you are connecting a diode in a circuit. You have to clearly know its anode and cathode terminals. Now there could be many types of diodes. In earlier days you all know that tube diodes were there, but nowadays it is all semiconductor devices and we call it PN diodes. Now in PN diodes or NP diodes, little bit of theory is required. If this is P layer, this is N layer, there is one junction, say J1, this terminal and this terminal will come out, this is anode and this is cathode. It could be NP also. If I change it like this will be anode, this will be cathode. In P type of layer, you know, the positive holes are the majority charge carriers, and in N type the negative electrons are the majority charge carriers. Of course there are certain minority charge carriers which will be electron in this case and positive hole in this case. Both are helping in conduction. Now to know which terminal is anode and which is cathode is very, very important. Here some of the diodes are there, you see, all these are semiconductor diodes. These are PN diodes or NP diodes. These are known as LEDs, light emitting diode. It is also a diode. When I give a supply across it, it will emit light. So it is known as light emitting diode. This is a metallic diode. These are known as Zener diodes. The metallic diode, as you will see, is completely packed in a metal pack, and this has two terminals, one this, the other this. One of these two terminals will be anode, the other will be cathode. And this type of diode is also a metal type diode, but this is different. These two are known as Zener diodes. Zener diode is a specific diode which when conducts will give a constant voltage across it. Now I will first of all explain you how to know the anode and cathode of a diode. If you minutely see here or here, you will find that there is a white ring coming here. In some of the diodes you will find a white dot also. Now this ring or dot will indicate that this particular terminal is cathode and the other one is anode. This is of course physical testing. You can also test it with the help of a multimeter. The diode can be tested with the help of a digital multimeter and also an analog multimeter. So, in case of a digital multimeter, you have to put the multimeter in diode mode and then check whether forward biasing is given or not. In case you have given a forward bias, it will show little bit of voltage drop, that means conduction is taking place, and in case of reverse bias there will be no conduction. So, you can easily know which is anode, which is cathode, because you know which terminal of the multimeter is positive and which one is negative. Now, the same thing demonstration Mr. Singh is going to show with the help of a digital multimeter first. He has kept the digital multimeter in the diode mode, and now you see he has connected the reverse bias condition. The red cord was connected to the cathode and the black to the anode. Now he has forward biased it and some conduction is taking place. The same test for a metal diode, he has connected it reverse biased, so there is no conduction. Now he is changing it, connecting in the forward biased condition, and conduction is taking place. We can also test an LED. Here you see there are two terminals, one is a longer one, the other one is shorter. The longer one is anode and the shorter one is cathode. So he has connected correctly, that is forward bias, and conduction is taking place. He is now reversing it. Reverse it, and there is no conduction. So, what do you conclude? The diode only conducts in forward direction. This is a Zener diode. This also tests like an ordinary diode. In the forward bias condition it conducts, in the reverse bias condition there is no conduction. You see, meter does not show anything. Now we can also test it with analog multimeter. This is forward bias condition and conduction is taking place. When he reverses it, there is no conduction. Same test with the help of an analog multimeter. Only that you have to be very careful in case of analog multimeter. You have to know the positive and the negative terminals of the multimeter. We can check some of the damaged components also, damaged diodes say. He is going to test this power diode with the help of digital multimeter, and it is connecting it forward biased, and it is giving 0 resistance. What does it mean? It is a short diode, 0. So it means it is a short diode. Similarly, in case of an open diode, you see there is no reading at all, no conduction. Reverse it, again there is no reading. This means that this is an open diode. Thank you. So now we go to the second component, which is transistors. Transistor is a 3-layer semiconductor device. So I can draw it like this. There are 3 terminals, the emitter, base and collector. Here you see that there are 2 junctions here, one is J1, the other is J2. In case of diode you had only one junction. Here, since it is a 3-layer device, you have 2 junctions J1 and J2. Now I have drawn PNP type of transistor, which means this and this layer will have positive holes as majority charge carriers, whereas this will have negative electrons as charge carriers. There could be another type of transistor which is NPN type. again 3 terminals, emitter, base, collector. Now, for conduction you have to bias it, and biasing is done like this. The emitter base junction is always forward biased, means you have to give a positive here, a negative here, and this junction has to be reverse biased. That means you have to give negative here and positive here. This is the biasing of a PNP type of transistor. Now, NPN type of transistor, again emitter base has to be forward biased. That means this will be negative here, this will be positive here, and collector base will be reverse biased. So, this will be, since this is negative, this will be positive here and negative here. So, this is the biasing of a PNP type transistor and NPN type of transistor. Now, once you have to connect it in a circuit, you have to bias it also, and for that you have to know the terminals very clearly, the emitter, the base and the collector. For knowing the terminals, what is important is you have to know some tricks. There are certain tricks by which you can know which is emitter, which is base, which is collector. Now, if you come here, you see all these are transistors, but you will find that these transistors are metal packed, whereas this is a different type of transistor which is plastic packed transistor. In case of a metal packed transistor, you will find, for example, here there is a notch. Can you see it very minutely? There is a notch coming out, and then there are 3 terminals. You count it clockwise, emitter, then base and then collector. I can draw it here. If this is the notch, 1, 2, 3 terminals are there, you can say this is emitter, this is base and this is collector. This is usually the practice, but in case of a plastic packed transistor, this will not be like this. You have to see it in front, where there is something printed here, you keep it at front, then you will find clockwise emitter, base, collector. So, it is something like this. Something is printed here, 1 terminal, 2 terminal, 3 terminal, clockwise emitter, base, collector. Is it correct? Now, this diagram what I have drawn here and here, they are known as the layer diagrams for PNP type and NPN type. This can also be shown symbolically like this. Here, if it is a PNP type of transistor, on the emitter terminal you put an arrow inside, this is base and this is collector. For an NPN type of transistor, same diagram can be drawn like this. This is base. If this is emitter, this is coming out, and this is collector. Now, one thing very important regarding transistors is you have to know while using whether it is an NPN type of transistor or a PNP type of transistor. That can be very easily checked with the help of a multimeter. What I will do is I will test this diode junction, this diode, PN diode or this NP diode with the help of a multimeter. So, I will keep my multimeter in a diode mode and test it at this diode between B and E, similarly between B and E. Now, look here carefully, this is an NP type of diode. If I give a forward bias to it, then only it will conduct. That means, if I give a positive supply to base and negative to N emitter, it should conduct. And I know my multimeter terminals. That means, if I connect it positive forward bias, then only it will conduct. So, I will definitely know which type of base it is. If I have connected positive of my multimeter to base and negative to emitter and it conducts, that means the base is positive. and it is nothing but an NPN type of transistor. Reverse is the condition here. If I put my negative of multimeter to the base, positive to the emitter, and the device conducts, then it is N base, that is PNP type of transistor. Now there is another type of transistor. Look here, this is a metal body transistor, and as this shows its size is very big. It is known as a power transistor. I can show it here, the same transistor. It is in my hand. Look here, only two terminals are coming out. See, one terminal is this, the other terminal is this, and the body. So here there are no three terminals, but only two terminals are coming out. It is a power transistor. Here the body of the device, it stands for collector. It is always the collector, and rest of the two terminals will be either emitter and base. Now how to know which is emitter, which is base? You keep it like this. There is a test for it, physical test. You keep it like this, and you will find that if you find out this distance from this hole to this, it is slightly more than this distance. Again I will repeat, from this center to this hole, this distance is more than from this center to this hole. You have to do it when you are finding out. You have to keep it like this, that the longer the distance should be at your right hand side. So if you are looking at like this, your right hand side is this, you keep this thing at your right hand and this thing at your left hand. Then the bottom terminal, this will be base, and the top terminal will be emitter. Of course the body is collector. So all these things can be tested with the help of a multimeter, and I would now request Mr. Singh to demonstrate it on the multimeter. Now he is checking which type of transistor it is. So he is given positive to the base and negative he is checking with the other terminal. So it is an NPN type of transistor showing conduction. Change it, again conduction is there. So it is confirmed that it is an NPN type of transistor. Now he has to check collector and emitter terminals. Collector and emitter terminals you check. Yes, some voltage drop is appearing here. Now change it. Some other voltage drop is appearing. The voltage drop which is more will show you emitter. Now he is checking the PNP type of transistor. So negative has been given to the base and positive, yes. So it is showing conduction. Reverse it, again it is showing conduction. So it is a PNP type of transistor. Now show the terminals. This is the voltage drop between base and emitter, and this shows the voltage drop between base and collector. Now you see, more the voltage drop will indicate the emitter terminal. Now there is another way of checking. There you can find out that there are two sockets on the digital multimeter. One is NPN, the other is PNP, and the terminals are marked on it. If you connect it properly, you can check it on the HFE mode. He has placed it on HFE and it is showing some gain HFE. If you connect the socket properly, then it will show, otherwise it will not show. So it is confirmed that which type of transistor it is. So this is also a check by which you can find out that the terminals are correct or not and which type of transistor it is. Change the transistor please. Yes. Again it is showing gain. If it is wrongly connected, it would not have shown this gain. So this way also you can find out which type of transistor it is and which are the terminals, emitter, base and collector. Now the same test can be done for a power transistor also. He is checking the voltage drop between base to emitter, between base and emitter. It is showing 477 millivolt, and between base and collector it is showing 473. So emitter was more, so the top terminal was emitter, bottom is base and the body is collector. Thank you. Now we go to the last component, that is UJTs, uni-junction transistors. Uni-junction transistors, as the name indicates, there is only one junction. Now just now you saw, in case of a transistor, we also call it bi-junction transistor, there were two junctions. Here it is uni-junction, so there will be only one junction. It is shown like this symbolically. This is the junction which is formed between this layer and this layer, and there are again three terminals, one which is known as emitter, then two bases are there, two base terminals are there, and I have purposely written this as base 1 and this as base 2. It has a significance, I will explain it. You see that this terminal, which is emitter, is nearer to B2 with respect to B1. If I compare this distance, emitter and base 1, that is more than emitter to base 2. That is why I have put this as base 1 and this as base 2. Now once I say this is base only, how do you say there is a layer or junction? It is like this. The construction can be shown like this. This is an N base, N silicon base, and in this base there is a diffusion of P layer. Now this becomes a PN junction or NP junction, and here the emitter is taken out. This is base 2, this is base 1. If you see little bit of its construction, you will find that this geometry of this base is such that the same base has been divided into two zones of resistances. One resistance is slightly more, the other resistance is slightly less. This is base 1 and this is base 2. Now terminals are 3, emitter, base 1 and base 2. Whenever you have to connect it in a circuit, you have to be very careful about its terminals. Now there are methods to know which is the which terminal. Here you can find out this is a particular UJT or uni-junction transistor, and usually in the market you can find that there is the device is in metal pack only, and there is a notch coming out here. You can find out there is a notch coming out and 3 terminals are here. One of them will be emitter, the other one base 1 and the last one will be base 2. Now if I draw the plan of it, you can see it like this, and suppose this is the notch, then you go from notch clockwise like this. You will have one terminal here, one terminal here, one terminal here. This is emitter, this is base 1 and this is base 2. This is one way of finding it out. Find out the notch, then the first terminal clockwise will be emitter, next one base 1, next to base 2. Another method of finding it is that if you see these 3 terminals, they form a triangle. Any 3 terminals will form a triangle. The triangle is like this. Now here you will find that between these 3 terminals, one of the lines will be the longer one. It will be the longest rather. So if I keep that as the base of the triangle, I will say that is the base, and the opposite point will give you apex of the triangle, which is always emitter. Now you count it clockwise, next to emitter will be base 1 and the next one will be base 2. So this is another physical method of finding out which one is emitter, which one is base 1 and which one is base 2. But the same thing can be tested with the help of a multimeter also. For that, you have to know the resistance between emitter and base 1 and also the resistance between emitter and base 2. Now here I had given you an indication that emitter is nearer to base 2 with respect to base 1. Then what do you think? The resistance, if I find out the resistance between emitter and base 1, it should be slightly more than the resistance between emitter and base 2. Same is the test, and we see it with the help of a multimeter. If I find out the resistance between emitter and base 1, it should be slightly more than. That means resistance EB1 is greater than resistance EB2. This is the test, and we find out the terminals with the help of a multimeter. Mr. Singh is going to show you the same. So now we are going to check the UJT with the help of a digital multimeter. So what he is doing is he is checking the resistance between emitter and base 1. It is coming out to be 160, around 160, and emitter and base 2 is 145.5. So it is lesser than the resistance between emitter and base 1. So that way you can check which is emitter, which is base 1 and which is base 2 in case of a UJT. Thank you. Now one very important thing about UJT is its VI characteristic. I would like to explain it here. The device UJT is a very peculiar type of device. It starts conducting only at a particular voltage. Before that it does not conduct at all. So if I draw the VI characteristic, it will be like this. You know what does it mean? This is current, of course, and this is voltage. So you find that this point is 0, so this is minus current, negative current. That means this is known as the cutoff region. Here the device does not conduct at all, the current is negative. And at this point, which is known as peak point, and the voltage corresponding to this is known as peak point voltage, the device starts conducting, but it has a negative resistance characteristic, drooping characteristic. And here you find that it is decreasing, but here the voltage remains constant, almost remains constant, and this particular voltage is known as valley voltage. So the valley voltage and the peak point voltage are very, very important specifications of a UJT, and commonly used UJTs are 2N, 2646 and 2N, 2647. For these, the peak point voltage is 7.9 volts and the valley voltage is 1.5 volt. So with these specifications and this type of testing, you can choose your UJT and connect it any circuit. So friends, in this film we have discussed about three very important components: the diodes, the transistors and the UJTs. In the next film we are going to discuss a very, very important category of components. It is known as the thyristor family. Thank you.